Yeah, but thank you everyone again for being here. I think that we're off to a pretty good start to the pre-day so far. A little bit of mic feedback. Yeah. Okay, so my name is Libbing. I'm a product manager on AKS. I specifically work on data plane performance, but we're going to be talking a little bit about developer productivity today. So today's presentation will be from code to cloud quickly with Azure Kubernetes Service, AKS. So we're going to be presenting on how you can go from just code to full cloud deployment in very little time by using AKS, as AKS will provide you with the tools to take something that is usually maybe a frustrating or difficult or time-consuming process to a much easier experience. And so I'm joined here today with Brandon Foley as well.
Hey, I'm Brandon. I am a software developer on the AKS developer experience team. Yeah, go ahead.
Yeah, so just before we jump into the presentation a bit, just a reminder to everybody, I have to click. Just a reminder to everybody to fill out the survey, please. We'd love your feedback. Any specific questions, comments, concerns that you have, you can leave in the survey. And it's just very useful for all of us to have your input. So just want to frame the scenario real quick. Welcome to the team. You're a brand new developer on a new team, and you've been tasked with creating a new feature on an existing application. So you've essentially been set up with everything that you need to be successful. You have your access to your current Kubernetes cluster that your company is using and has set up. You have access to your GitHub repository. You have your laptop. So it's exciting times. You're going to be working with a lot of different things like microservices and Kubernetes. So you're very excited just to hit the ground running, to dive in. And so you want to be as successful as possible right away. So you begin thinking to yourself, you know, I have the code, I have access to the code, I can start touching that code right away. But then it kind of occurs to you, well, what else is going to be required to be successful here? What other blockers might I have through the journey from just code to a full cloud deployment? And so that's when you kind of realize a lot of other factors come into play here. It's not just code. You have things such as containers in Kubernetes. You need to containerize your application. You have things such as continuous integration and continuous delivery, which becomes a lot more complicated. Then you have obviously DNS certificate management, which then you get into more specifics, and you have just higher level stuff like monitoring and scaling. So it's no longer just code. It's a full suite of productivity that you need to be successful. And you need to be able to touch each and every one of these to go from just your code to a full cloud deployment. And so a common reaction to this, especially from somebody that's brand new on a team, just meeting people, just getting access to your tools is, oh no, this is a lot. You might be overwhelmed, you might be anxious, you might be nervous. It isn't just an easy process anymore. It's not just code. You need to employ a full suite of tools in productivity. But don't worry, because with Azure, you've got this. We have a broad range of offerings that are able to help you be more productive and be successful. And so here we have kind of the start of this journey, which it starts off as a developer, right? You have your code, you have your favorite IDE, and you kind of start from this point. So this is the beginning of the end-to-end path of the cloud journey. And so we can move on, from there with what you currently have. And so what your company's told you is that you have a GitHub repository that's using code spaces. And so one of the really cool things about code spaces, we'll touch on and give a quick one-on-one on before we get into the rest of the EDE process, is that it essentially gives you the full offerings of VS Code in a live in-browser environment. And so this includes a lot of things. Yeah, we have a question here. Follow along URL up there. Yeah, we can put that. Yep. So here you can click this URL, enter this URL to follow along with the presentation.
Everybody good?
We're all good there? Yeah, and so we have a lot of tools that offers with GitHub code spaces. There's your settings sync, there's version control, you have 32 cores and up to 64 gigabytes of RAM and compute. So it's a really powerful editing environment for your development. And so GitHub Codespaces essentially allows you to reduce the amount of friction that's in the onboarding process by standardizing the process for any person. So it no longer becomes, well, what project are you working on? What type of skills do you have? What are the dependencies required from the last person that might be handing off this project? You, using GitHub Codespaces, can standardize each of these tools. You can standardize the development environment itself. You can standardize the runtime, as well as a lot of other aspects of your environment in order to provide the least amount of friction as possible in the experience. So now we'll jump into the demo here of the first part of this development process, going from just code and taking the next steps. So yeah, we'll jump into the demo here. As you can see, remember, we're brand new to the team. We just received permissions to our code repository. And so in order to get access to that AKS cluster, we can run AKS get credentials. And so this will essentially tell us that we are currently using a Kubernetes namespace called Contoso Names. So that's where the front end of our application is currently deployed. You see that we have an external IP active there, so we can tell there's already a front end of our service running at that IP. So now we kind of have a little bit more information there, and the next step is obviously to type in that IP into our browser and to see what we're working with. What type of work do we want to do? And so when we type that IP in, we see, obviously, the service has not been deployed yet. It's not loading, and so this is kind of where we come into the equation. We need to set up the back end of this service so that it can serve the front end. And so, yeah, so what we do here is we remember that we have a GitHub Codespaces environment set up with our company. And so we go to our GitHub repository. And so, you can see everything that we've been essentially given here for our backend and the Contoso name service. And we want to set up our code space. And so we're setting up our code spaces, and what's really cool is that this gives us a lot of flexibility in terms of how we want to work. We can edit here live in the browser and view all of our tools here live in the browser, but if we prefer using the desktop app of VS Code, we can also launch it on our desktop app and develop remotely instead. And so here we're setting up the code space, and it's going to have all of the dependencies already pre-filed into the code space so that we don't need to worry about anything like that. There won't be any blockers to actually touching the code once this code space is set up. So as you can see here, we just have a pretty basic project set up, basic service. Nothing complex is going on here. There are no Kubernetes or Docker files. This is a simple .NET 6 service. So we can jump into the code and look at, what's specifically going on here. What's the purpose of this service? And so we see this function here for, essentially, it generates random names, very basic. Once again, nothing complex going on here. And we have the endpoint /names. So the logical next step would be to test out, this backend code to see what's going on. So we can run our debugger just like we do with any other, project or service that we've been working on. Nothing different. And we see that the code executes and that everything looks all good. But it's very important to note that, this is not running on a Kubernetes cluster yet. This has not been containerized. This is purely running on GitHub Codespaces. So the logical segue here is, how do we take what we have currently in this code space and containerize it and put it on an AKS cluster?
And so what do we do next, right? We have our code in code spaces, and we need to get our Contoso name service running in Kubernetes. So what's the first thing we need to do? Containerize our application, right? And how are we going to do that? Well, we could start writing Docker files line by line, searching for the correct, image to start with and the correct version. Or we could use a tool like Draft, which can do a lot of that for you. So you might be asking yourself, what is Draft? And Draft is an open source project that we've been working on that kind of acts like a template generation tool to generate things like Docker files, Kubernetes manifests, and GitHub workflows for you with just a few simple inputs. And if we wrap Draft in like a CLI or a VS Code extension, for example, then we can use tools within those ecosystems to maybe look at your cluster or your repository and be able to give you better options to input into those templates, right? And so that's kind of where the AKS developer experience Visual Studio's extension came in. where we wanted to make it super simple for developers to get things done within their cluster, right? Whether it be those simple create a Docker file or Kubernetes manifests or some other things, which we'll go into. So let's take an example of trying to create our Docker file, right? So first we'll come in, we're in code spaces. Let's check our settings in code spaces and make sure that we have the correct extensions installed. So we can come down here and see, yes, we have our ms kubernetes tools.vs code AKS tools, perfect. And then in the features, we see, yep, we have AZCLI, perfect. That's where we're going to get draft from. And so this looks good. We should be good to check out the actual extension page for the AKS developer experience. Just check and make sure it's there, installed. And here we can see it's there. Awesome. So to get started, the first thing we're going to have to do is sign into Azure. And that's so we can get access to the cluster and other Azure resources so that, again, like I said, we can look into those and give you better options to fill these templates out. So we'll sign in. And once that's complete, we'll head over to the Kubernetes extension in VS Code. We should be able to see our cluster in Azure under our subscription. Perfect, Contoso cluster. We'll add that to our kube config and then see what's inside. And of course, we had our Contoso namespace, so we'll set that as our default. Awesome. And we should be good to then run draft through the command palette and generate our Docker file. So open up the command palette, search for draft. You can see a few options in there, and we'll select selected Docker file. And then you'll be asked to insert in a few things, right? Your source directory, your language, your language version, and the port that you'll be running on, right? And as you can see, it generates a Docker file, no problem. Awesome. So, I think we went double. All right, so we got our Docker file generated. What's the next step to get onto Kubernetes, right? Get this app deployed. It's going to be generating Kubernetes manifests. So, Kubernetes needs to know where is our image located? How are we going to expose this service? How are we going to route traffic to this service? All these things, right? And all of these Kubernetes resource definitions are usually done with YAML, right? So what are we going to do here? Again, are we going to just start writing YAMLs? Maybe we'll head over to Stack Overflow, copy some examples, put it in and try and get things working. Or again, we can use draft to make it super easy with just a few inputs. So let's take a look. So coming in here, you can see we just successfully created our Docker file, and we'll click build. So we'll go through pushing this image to ACR. So we'll give it an image name and an image tag, and then selecting our Azure Container Registry, which we have one that we already created, so we'll just use that. And now this will build and deploy our image to ACR. And it will take a moment. But then once that's done, we should be able to generate our Kubernetes manifest and be able to use the image that we just pushed, right? So an important first step to successfully creating our manifest. No, not yet. Need a fast forward button, Yeah, nice. Okay, so once that's completed, then we can go through the command palette again, open up draft, and do the create a Kubernetes manifest. And then, so we'll go in here and it will ask us a little bit about what we need to generate, right? The service, where we want to expose it, and some other things, the port, right? And you should be able to see here that we have a deployment and a service YAML, right? And then here, our service YAML has a load balancer, but that creates an external load balancer, which we kind of don't want for this, just because our front end only needs to hit the back end service. So we'll just create a cluster IP here. And then when you successfully generate your Kubernetes manifests, there will be, and you can see here the ACR put in successfully as well, pointing to our image. And again, when you successfully create your manifests, you'll get this nice little pop-up, and then you can just click deploy, and that will open up the CLI or terminal and apply that deployment for you. And so now we should be able to actually check on that deployment in our cluster and see it running. Awesome. Yeah, there it is. Contoso name service, 13 seconds. Perfect. So now we should be able to go, hit our IP, and then once we actually hit this, now it works, right? So we have our Contoso name service running in our cluster. We're able to hit it. Oh, but looks like we have an issue here. We're getting adjective adjectives instead of like adjective nouns, which is kind of what we were hoping for, right? So looks like we got some bugs. How are we going to handle that? That is the question. We can go to the next. So we've deployed our app. We see it running, but we've got bugs. So how are we going to go about fixing these bugs, right? Now, for this, we have multiple microservices that are running, and it could be difficult to get everything set up locally to try and test end to end. But there's tools like Bridge to Kubernetes that allow you to set up just portions of your app locally and use resources within the cluster to route traffic from the cluster to your local development environment. And it also allows you to do subdomain routing as well. So you can create a custom subdomain, and only traffic that hits that subdomain will be routed to your local environment to do debugging. So you won't have to, potentially if there's more developers using this environment than just you, then you won't have to block them from using the environment. You can just set up your own subdomain. So let's take a look at how that will work. So we'll go check out the Bridge to Kubernetes VS Code extension, make sure it's installed. Looks good. And then from the command palette, we can do Bridge to Kubernetes here, and we'll create a new configuration for our app, right? And so this will look for what services that you want to run locally, and we'll do our Contoso name services. And once we select that, it will ask where we want to run the app locally, and then it will ask about a debug configuration, and then it will ask again about the subdomain, if you want to do all traffic routing to your local host, or if you just want to do specific traffic under a subdomain. And so we'll choose the subdomain option. And perfect. So now it's created a launch configuration, so we can go over to the debug tab in VS Code, and you'll see that we have this new .NET Core launch with Kubernetes. And so we should be able to hit that, and this will deploy resources to your cluster to handle all of that routing for you, right? And creating the subdomain, all of that. And then it will also run the app locally, so you'll have that end-to-end experience with some things in your cluster and some things local. All right, so we can see our application here is running. And we'll go back to the command palette just to see the bridge options. And so this was our names application here, super simple. Go to the command palette, and you can see here that we have our two options for opening in the browser, the front end and then the front end behind the isolated subdomain. And of course, we're trying to debug, so let's go to the subdomain. So we'll open up in a new browser. It will look exactly like we saw before, but now when we hit our surprise me, we can see logs coming through locally. So let's set a breakpoint and then run it again. And you can see we hit it. So now we can step through to easily debug our code. I can see there on line 31, it looks like we have adjective, adjective, easy, simple fix. We just got to change that one. So now we should be able to make that simple change, and then we can run this debug configuration again, and that should allow this app to run locally, but when we put traffic through the subdomain, it will hit our app that shows the bug is gone now, right? So we should see adjective nouns instead of adjective adjectives for our awesome band names. Go. So now it's back to running. We can open it in the browser, refresh the page. You can see that, yes, now it works. Zealous Pair of Binoculars, great band name. And you can see we're still on the subdomain here. And if we go back to the original IP, you'll be able to see that it still doesn't work, right? Because that code is running in the cluster, whereas this is running locally on our development environment. Awesome. So from there, this is good. We need these changes, and I think other people need these changes too, right? We want to make sure that they're not seeing a bad experience. So let's make a new branch and commit these. And then we can talk about how we're going to give other developers this and get this code running in our cluster in a more automated way than just deploying it ourselves. So we create the commit, merge it. Should be in our new branch. Awesome. All right. So we've debugged our Kubernetes application, found out what's wrong, and now we're ready to get the code back out into the cluster with the fix, right? So how do we want to do that? We want to make sure we do it in an automated way so that every time we make changes and push, it can happen automatically. And GitHub Workflows is a great way to do that. And using Draft, we can generate a GitHub workflow that will allow you to make this happen, right? And if you go to the next page, the GitHub Workflows allow you to automate the testing and building and publishing and deploying of your app to Kubernetes clusters based off simple GitHub events, right? Like pull request merges or new releases, things like that. So let's take a look at how we can create an automated deployment through the Azure portal for our cluster. So we'll head to the Azure portal and go to our cluster page. Contoso app, perfect. And under the settings on the left side, you can see automated deployments. So we'll hit that, come into this page, and create an automated deployment. So this will go through a few pages asking you to input some information, right? So workflow name, this is going to be the name of the workflow within GitHub, and then connect to your repository that you want. For us, should be the Contoso name service. Contoso name service, nice. And then we can go to the next page where it will ask a little bit more about the image, right? So we just created the Docker file and pushed that image to ACR within VS Code, and now we can use that Docker file from within the repository and use the ACR image that we pushed. And we got to remember to select the Docker file. Always forget. So this will open up a little window over here, File Explorer, to select the Docker file. And then we can go to the next page where it's all about the deployment configuration, right? And so this is based off of what's in the repository currently. And so for us, we did Kubernetes manifests, right? So we can select Kubernetes manifests, open up the little File Explorer window here, and then go for our manifest folder that we generated and select the service and deployment files that we also generated with Draft. And for the namespace, we know we've been using the Contoso names, so we'll keep that going. And now we review and create. So when you click create, it will create some federated credentials for you to let the GitHub workflow be able to access resources within Azure, right? It needs to be able to push to your cluster, be able to pull from ACR, push to ACR. And then we submit a pull request against your repository with this new workflow. So once that's done, we can go ahead and take a look at the pull request. And so this should open up GitHub to the new workflow that we generated. We can check out the files changed. And you'll see we were able to take in some of the information from the forms you filled out and set the environment variables that we use throughout to accomplish two major things. One is building and pushing your image to ACR, of course, and then deploying to your Kubernetes cluster. So here, you can kind of see this is where we run the AZ-ACR build to push your image to ACR. And below is where we are deploying the application to your Kubernetes cluster. This looks good to me. I think we should merge it. And so once we merge it, we should actually be able to head over to the Actions tab and see everything start to run immediately. So it's merged. We'll head over to Actions, and we can see our workflows running. We can go in to get a little bit more information. You can see the two stages here, build and deploy. And when you click on those individually, you can get more information on the individual steps within these stages. Speed things up. Awesome. So we built the image successfully. We deploy successfully. Now we can head back to the portal and see in the automated deployments, we have our Contoso name service. And we hit the workloads, and that will bring us to our workloads page where we can see in our cluster the Contoso name service workload. And then in here, we can see that it just deployed, right? So we're able to set up our GitHub workflow to automatically deploy our app to our cluster. Let's hit the IP and see. Yep. So now our changes. No more adjective, adjective. Now we get adjective, noun in here. Awesome. Yep. So automated deployment successful.
Awesome. So now we can move on to kind of towards the end of the process here, where we're talking about the operator side of things. So this involves more about the web app routing and the ingress, and maybe you have an operator or you yourself are the operator. So this is kind of where we head to next. So we'll jump back into the demo here. And so essentially your team has let you know that you also have a GitHub repository for your front end. And so, obviously this is what wants to be involved with the entire part of the ingress. So you go to the repository, Contoso names front end specifically for your front end. And now you want to jump back into code spaces, and kind of like I said before, again, you'll have all of the extensions required, all of those dependencies that you need pre-populated in there, so you won't have to worry about any blockers. And so we jump into the code space specifically for the front end here, and something that we can do now to draft the ingress is use the draft Kubernetes ingress command. And so by using this command, it'll first ask us, obviously prompt us with a few different questions. The first of which is, to which service running on Kubernetes do we want to point the ingress to? So we can go ahead, answer that question. Next, what port will we be running on? In this case, 80. And then we can now set the host name as well. So we'll go into that. And so again, we're using the front end specifically. So we want to make sure that we have that in mind here. So we'll go in and populate this. And a great option here is that we even have the option to use Open Service Mesh for mutual TLS. And so if that's something that we wanted to use, we could elect to use that. In this case, just for the pure sake of simplicity, we won't be using that, but it's good to know that there's an option there. So the next steps essentially will be using Key Vault to populate the cert URI parameter in our YAML file. So as you see here, we jump into the YAML file. We go to our cert there, and we see that there's a preset cert URI field. And so that's where we want to populate. And so in order to get that field right there, the next thing that we're going to do, given that we have an operator and they provided us with some information, we head back to the Azure portal. So we type in the portal there, the URL, and we want to head to the Key Vault page in the dashboard. And so when we go to our Key Vault, we'll see that we have a certificate already here that's been actually provided to us by our operator. So we have this SSL certificate, and so it's important to note that this is a self-signed SSL certificate, but you can actually upload your own SSL certificates that are self-signed using Key Vault, or you can even generate some new ones using some of Azure's partner offerings. So now that we grab that cert there and paste it into the cert URI parameter, things are looking pretty good. We can try and apply this change to our Kubernetes cluster to actually see the change live now. So we open up our terminal and decide to actually apply that change there. And so, specifying for the front end. So that's what we're currently running there. And so looks all good. It looks like that change has been applied. And so something that's unique here is that the Azure DNS and the external controller are actually linked. So in a few minutes, we'll see that, number one, the DNS has been populated with a new A record. And number two, the service will actually be live. And so we go back to our Azure portal here and go into our DNS records, and we'll see a brand new automatically generated names app, A record for us. And so we can go over there and grab essentially the DNS name if we want to go see our live service. And so we grab that name there, and we want to head back to our browser, paste that name into the browser, and we can go check out what's happening with our service now with an actual DNS set up. So we paste that in, and now we see that our service is actually protected with HTTPS. And so it's important to note it doesn't say that it's secure. That's because we are using a self-signed certificate, but if you bring your own certificate, you can have a HTTPS secure server at any time. You can bring your own certificate and this won't be a problem. But essentially now what we've accomplished is we have a fully set up containerized application. And we've gone all the way from the stage of just having code to having code that's now hosted in a Kubernetes, or running on a Kubernetes cluster that's been containerized and that's set up with a DNS and ingress. So it's an externally facing application. You have everything you need there. It's functioning properly. It's been debugged. So this entire process essentially has just been a testament to the fact that you can accomplish each of these steps from developer to deploy to push to operator all in the scope, this time span of this presentation. So something previously that could have been a huge blocker for somebody joining the team. Imagine you're trying to backfill a position or hiring somebody for a very important project. This could be an extreme blocker to somebody to try and ramp up, to gain access, to get those credentials, to have those dependencies in place. Now we no longer have those blockers. We're able to go through each of these steps very quickly, very efficiently, and effectively improve our overall developer productivity with quite an amount of ease.
So on the developer experience team, we've been thinking a lot about what we should do next, right? Building on top of these tools, but we really want to know what you guys want, right? Like, do you never want to touch a Kubernetes YAML resource ever again? Do you want to be able to deploy, debug tools to your cluster that you can use from VS Code? Do you want to maybe be able to swap out like service mesh offerings with a click of a button to see what works best for you? So I kind of will leave it open to the floor if anybody has anything that they'd like to see.
Yeah, if anybody's very passionate about this, please raise your hand, provide your feedback. If you'd like to stay quiet, that's no worries. We have this link right here where you can provide your feedback and fill it out. Yep, right here.
So one of the things that I end up dealing with a lot is when builders or frameworks don't work quite how I expected them to inside my own environment. What I would love to see is whatever is generating the configs to have something that has a link to documentation about it, something that can actually explain what was generated and why. Because when you're into troubleshooting, when you're using like controlled egress, why it didn't get out, what it didn't get out to, what it was trying to get to, what it was expecting back, those all become a bit of a yak shaving exercise.
Yeah, I agree. And if anybody couldn't hear, he said that, when you're using tools like this that are generating things for you, you might not know what is generated, right? So having that documentation on this is very important, and completely agree. So definitely make note. I see somebody, oh.
Hi, great presentation, by the way. This is a bit off topic, but I was wondering, I noticed that you guys used GitOps through like the Azure portal on AKS to use like GitHub Actions. Would you say it's more of a comfy experience than something like Azure DevOps?
So
pipelines and boards? We
actually didn't use GitOps through this. It was a different automated deployments flow within the portal.
Okay.
I don't know if that really answers the question, but.
Yeah.
Sorry?
That was in a preview mode, right?
Yes, it is in preview mode. It is, yes, it is public preview mode, so you should be able to see it. And I know I did see a hand back there.
Oh, making me run?
Yeah, get those laps in.
So my question is, do you guys see more of like these YAML configs going towards more of an easier like UI, where you can just insert your specifications to like your ports and your namespaces and stuff?
Sorry, could you say that again?
So I guess like, do you see this becoming more popular where we're going to start automating like the template for YAML, and we just input the like config specifications?
I think it's very beneficial, right? Because it takes a lot of effort out of developers. If you're like, hey, I want to use an Nginx Ingress controller, then I can look at your Kubernetes cluster and tell you like, hey, these are the services that you can use. Maybe if you want to have specific routing, we can set that up for you, right? Rather than you having to go through and try and nitpick these things. I do see that there is kind of, like the other gentleman was talking about, when you generate these things, people might not know what actually happens in the back end, right? Like when you generate it, you don't know what it means. So at some point, yes, we do need to have some good documentation on what we're generating, things like that, but I think it will be, yes, beneficial in the future and move towards this.
And if we were to keep moving towards this, is there like an active community right now that would maintain these templates and update them?
Yeah. So here, this URL will take you to the draft GitHub discussion page, I believe. And so our team owns Draft, and we will be taking care of those templates. Now we hope to, work with other open source teams on templates for their offerings as well, but soon to be.
Cool.
Great presentation. I had a follow-up question. Maybe you answered the other gentleman's question. Did you say it was integrated with Azure DevOps? Can I run this demo using Azure DevOps or no?
So this specific demo through the portal uses automated deployments, which doesn't use the GitOps. It just creates a workflow, a GitHub workflow that deploys using, depending on either, customize Helm or Kubernetes manifests. It will choose either Helm or kubectl, right?
Okay. And the YAMLs that drafts generates, can you use it on Azure DevOps, or is there something else? Is it not compatible in any way?
I am not sure on that one. I'll have to get back to you. I think it should be. It's just Kubernetes resource definitions, so should be okay.
Okay. Final question is, if I want to run through the demo, does this only run on the Azure AKS, or is there on-prem, can I run this demo somewhere?
So are you talking about the portal portion?
Yeah, the demo that you showed and the link that I followed through.
Yeah, you should be able to run the VS Code like wherever, right? And then the portal you'd have to run within the browser. I'm not sure. We wouldn't be able to send it to your cluster. You might be able to change GitHub configuration to point it to a different cluster.
Okay. All right, thanks.
Yeah, and if any of you would like to learn more about specific points of this presentation, such as the deployment, the automated deployment, you can feel free to leave a comment or reach out to any of our resources that have been listed here, and we'll happily get back to you with more information about that. So here, once again, another reminder, you're going to hear it a million times today, but please fill out the survey. We'd really appreciate it. And then any of the resources that were included in this presentation are listed here as well. Lots of really, really good information, so we strongly encourage you guys to check out any of these links about anything that you would be interested in, because I guarantee you it can answer a lot of questions and also give you a lot more to think about, maybe give yourself some questions too. So thank you everybody again for coming today. We really appreciate your time. You have another question here?
Slide deck.
Yeah, so I think we're going to be sending out slide decks afterwards. We're going to, save a version of this, include all of this. Yeah, yep. Cool. Thank you.